Hello everyone, in this video we're talking about spanning trees. So what is a spanning tree? A spanning tree is a subset of a connected graph that has all the vertices with the minimum number of edges. Alright, so as you can see, graph G's are connected graph, and a connected graph usually forms a cycle or a cyclic. Alright, and you can see that A, C, and B, the graph forms a cycle. Alright, so therefore it is a strongly connected graph. So, and from the strongly connected graph, we could form a spanning tree. So the first thing we're going to do is, how do we find the number of edges for the spanning tree? So we count the vertices. 1, 2, 3. We have 3 vertices. This is the formula to find the edges for the spanning tree. And this will apply to all the spanning trees for this graph. Again, all the spanning trees will have the same number of edges and vertices. All right, and the spanning tree will not have a cycle. All right, so what we do here is, for the spanning tree, ST stands for spanning tree, is this graph. So we have 3 vertices, 3 take away 1, and this ST edge here, put E, will equal 2. So, okay, so a spanning tree for this graph would look something like this. We have all our vertices and we have the minimum number of edges. This is our spanning tree, and it's a disconnected graph. All right. Now the next question is, how do I find out the maximum number of spanning trees I could have for this graph here? Simple. You get the number of vertices. We have 3 vertices. I just want to make this clear that B here equals 3. Also E equals 3 edges. Okay. So we go 3 to the power 3, take away 2. This one. So here, the maximum number of spanning trees we can make from this graph here is 3. And let's do it right now. Let's make all the possible spanning trees. So ST is right over here. A, C, and B. All right. A, C, and B. This one here. A, B, and C. These is the maximum number of spanning trees, and this is the combination of all the possible spanning trees we could have from this graph. And as you can see, they have the same number of vertices and the same number of edges. And I just want to make this clear. This will apply to a graph that's a connected graph that has 100 vertices and 100 edges, 1,000,000 edges and 1,000,000 vertices. This formula will apply, and the properties will apply. The spanning tree properties below will apply to those vertices and graphs that have thousands and millions in their graph. All right. Now, let's get into minimum spanning tree, minimum cost spanning tree, you could say. All right. What is the minimum cost spanning tree? We have weights here. So now each edge has a weight. So as you can see, from A to C, it's 7. From A to B, it's 8. And C to B is 10. All right. So the minimum spanning tree is the minimum total cost of edges. So it's the minimum number of sum of all these edges, right? So let's find it here. What's the lowest, the minimum edge here, the lowest number in this graph? We'll call this graph here G. What will be the minimum spanning tree cost? It will be A and C. 7. All right, what's the next one? We could have from the previous one, we could have 2 edges here, but we have to have 3 vertices. All right, so it's either going to be 8 or 10. It's 8. The next minimum edge is 8. All right. And then the cost for this tree, minimum spanning tree cost, 7 plus 8 equals 15. So the minimum cost is 15. All right. And this is the minimum spanning tree. Oops. This is the minimum spanning tree for the connected graph here. And what algorithms do we use to find the minimum spanning tree? We're going to talk about it in the next videos. We use Prim's algorithm and Kirksaall's algorithm. All right. And I want to thank you guys for watching this video. And I hope you understand spanning trees and minimum cost spanning trees.